In this video, we're going to practice how to convert between different forms of a quadratic equation. I've already pre-printed two ways for writing the equation of a quadratic function. On the left, we have f of x equals a times x squared plus bx plus c. And in order to determine the coordinates of the vertex of the parabola, we will take the opposite of b divided by 2 times a, and that will give us the x coordinate. And then we'll substitute this x coordinate into the equation for x to find out what the corresponding y coordinate would need to be. In the second equation, we have f of x equals a times x minus h quantity squared plus k. In this form, the coordinates of the vertex are actually visible in the equation itself. We don't have to calculate them. H is whatever number is being subtracted from x, and k is the value that is added at the end. Let's practice how to convert from one form to the other. Here's an example we can practice with. Let's say we have f of x equals 3x squared plus 6x minus 5. In order to write it in the second form, we are going to factor out a 3 from the first two terms, basically the two terms that contain the x variable. So let's write this as f of x equals 3 times x squared plus 2x. And let's leave a little room before we put the second parenthesis here, because we're going to complete the square for that trinomial. And then let's just move the negative 5 off to the side. Notice that in this step, we have not changed the value of either side of this equation. We've simply rewritten it. Now I want to complete the square with the trinomial inside parentheses. Recall that in order to complete the square, we divide the middle coefficient by 2 and then square that number. In this case, we're going to divide 2 by 2 and then square. 2 divided by 2 is 1, and 1 squared is 1. So this is the quantity that we're going to add to complete the square. Now, in doing so, we have unbalanced the two sides of the equation. We've modified one but not the other, and therefore the two sides are no longer equal. One way to correct this is to modify the left-hand side of the equation in the same way that we've modified the right. Well, I don't think that's going to be very helpful because having f of x isolated is preferable. So the other way to correct what we've done is to undo what we just did to restore balance. So let's think about what we really did. On the surface, it may appear that we've added 1, but in essence, we've done something different. It looks like we've added 1, but in fact, we've added 3 because the 1 is also being multiplied by the 3 in front of the parentheses. So we've added 3 to the right-hand side of this equation. To restore balance, let's subtract out the same value. Now the equation is in balance. Next, let's factor. So we have f of x equals 3, and then x squared plus 2x plus 1 factors as x plus 1 quantity squared. Negative 5 minus 3 will give us negative 8. So we have the second form for writing the equation of a quadratic function, and this form will yield the very same graph as what we started out with. In fact, according to this new form, the vertex would be at the ordered pair negative 1 comma negative 8. Notice that negative 1 is what we are subtracting from x, right? X minus a negative 1 becomes x plus 1. And then negative 8 is what we are adding at the end. And so the vertex is negative 1 comma negative 8. Notice that that's exactly what we get if we apply this relationship here. So according to what we have in the original function, negative b over 2 times a would have been negative 6 over 2 times 3. And we have negative 6 over 6, which is negative 1. That matches exactly with the x-coordinate that we observed in the second form of the quadratic function. Then f of negative 1 would have been 3 times negative 1 quantity squared plus 6 times negative 1 minus 5. So that's equal to 3 minus 6 minus 5, which is negative 8. And that also matches with what we observed in the second form. So you see that by completing the square, we can convert from one form of a quadratic function to another. Let's practice with one more example. We're basically going to recreate the same steps we see here. So again, here are the two forms. Now let's go with f of x equals negative 2x squared plus 8x minus 1. We're going to factor out a negative 2, which is the leading coefficient, from the first two terms. So we'll write this as f of x equals negative 2 times x squared minus 4x, leaving some room to complete the square, and then we'll write the negative 1 at the end. Again, to complete the square inside parentheses, we divide the middle coefficient by 2 and then square. Negative 4 divided by 2 is a negative 2, and when we square a negative 2, we get positive 4. We've thrown the equation out of balance, so we've got to restore balance by undoing what we just did. Again, on the surface, it appears that we added 4, but we've done something different. We've actually added a negative 8 because 4 is multiplied by negative 2 as well. So if we've added a negative 8, the way to correct that is to add 8. Now the two sides are in balance again. Next, let's factor. So we have f of x equals negative 2, and then the trinomial x squared minus 4x plus 4 factors as x minus 2 quantity squared. And then negative 1 plus 8 becomes positive 7. So now we have the desired form for the equation. According to this new form, we can see that the vertex of the parabola will be at the ordered pair 2, 7. Let's just confirm that we would have gotten the same vertex if we had used the original form. So we have negative b over 2 times a would be negative 8 over 2 times negative 2. So that's negative 8 over negative 4, and that becomes positive 2, which coincides with what we saw earlier. And then f of 2 would be negative 2 times 2 squared plus 8 times 2 minus 1. So that is a negative 8 plus 16 minus 1. I said 1 and wrote 7. Let's get that corrected. Minus 1, and that equals 7. So that again matches what we found earlier.